Hello mathematicians and welcome back. On this video we're going to go through a few more of the Delta Math problems, specifically having to do with matrices. So if you've been having technical difficulties or just need some extra examples, then you're in the right place. Especially if you need help with the TI-84. I'm going to go through a few more examples using that. So hopefully this helps. So starting with the Intro to Matrices assignment, let's go to determine the order. Remember that the order is going to be the number of rows and the number of columns. So on this one there's one row, can't highlight it very well, but there's one row and there's a second row. So there's two and then 1, 2, 3 columns. That is a 2 by 3. Beautiful. And I'm counting down for rows. I have 1, 2, 3, 4, and the columns 1 and 2. Alright, hopefully that makes sense. If you're confused about order, I would just go back and watch my tutoring video about that. Sorry guys. Let's look at one where we identify the matrix elements. So the elements are written with the row first and then the column. So this would be the element that's in the second row and the first column. Well, we have a problem here because this matrix only has one row. So this is undefined, does not exist. Okay, cool. Okay, let's look at, this one's asking for 4th row, first column. So I'm going to count down 1, 2, 3, 4, and then the first column would be that element right here, 4. Just enter the number 4. There we are. Okay, one more. So this one's the element that's in the first row and the second column. Here, first row is the top row, and then the second column would be the second number in, which is that 8. So the order and elements should hopefully be easy practice problems. Great, now looking at some matrix addition and subtraction. First thing I notice, I have 3 rows and 1 column in both of these matrices. So my answer should have the same dimensions, the same order. So I'm going to change that down there. All right, now all I'm doing is adding elements that are in the same location. So A11, 1, or the first column and first row. I'm doing 1 and adding -3, which gives me -2. Oops, get rid of that. Okay, and then in the middle row there I'm doing -5 plus 4. Combining those I get -1. Okay, and last row, 3 plus 5 is 8. So nice and easy. Probably the part that maybe we didn't know was that we need to update the size of the matrix. That is pretty important. Let's do another one. So here, B minus A. First thing, I need to look at my order. Okay, these are 2 by 1 matrices, so I need to get rid of that second column there. And then I'm taking B minus A. So the top element of B is -3 minus -2. Same thing as -3 plus 2, which simplifies to -1. Okay, then B on the bottom is -3 minus A, which is 4. And those simplify to -7. Alright, doing great guys. One more. Okay, we have 2 by 2s, so our matrix here looks like it's in good shape. And this is B plus A. We're just adding together 5 plus 1 is 6. On the top right, I've got 3 plus 1 is 4. Bottom left, -1 and -5 makes 8 negatives. Just be careful when you're adding your negatives like usual. Make sure that we don't cancel things that don't cancel, etc. Alright, looks good. So that should be pretty self-explanatory. We can also do these on a calculator if we really wanted to. Might be a little more time consuming than it's worth though. We have a subtraction problem. Could do this by hand, or we can use our calculator. I'm going to try and make this smaller so it actually fits in the screen here. Alright, so first thing we need to do if we're going to use the calculator for matrices is enter the matrices. So I'm going to go to second matrix, scroll, edit, and we're going to go ahead and use matrix A for this one since that's what it is called. We need to enter the order first thing. So this one has 1, 2, 3, 4 rows and 2 columns. All right, and then I just enter the numbers. When you hit negative, make sure to use the negative sign, not minus, or it'll give you an error message. Okay, back to second matrix. And then I'm going to edit the second matrix, B. Again, this is a 4 by 2. And his quit. And I think that this method takes a little bit longer than just doing it by hand, but it is important to know how to enter the matrices, so it's a good example just for that. And then A minus B, it gives us our answer here. So again, I'm going to have to adjust this to say 4 rows, 2 columns, and then I can enter my answer. Okay, perfect. So that's how we're going to use the calculator. We're going to do this is determinant of a 2 by 2, so it's going to be, in my opinion, easier to just do this by hand. To find the determinant of a 2 by 2 matrix. So we're going to call this A, B, C, and D. And the determinant is found in AD, A times D. All right, so here's our formula for the determinant. For the matrix ED, we're taking AD minus BC. So we're taking these two, top left and bottom right, and multiplying them together. So in that matrix, that would be 1 times negative 6. And we're subtracting the upper right times the bottom left. So 3 times 5. 1 times negative 6 is negative 6. Minus 15 gives us negative 21. Perfect. So let's do the next one using the calculator so we can see how that's done. Go into matrix, edit. I'm just going to go ahead and use matrix A again. This is this time a 2 by 2. And second matrix, scrolling over to math. The first one is determinant. I can click on that. And then second matrix, I have to tell it which matrix to take the determinant of. And I'm picking A, and it tells me 30. Let's make sure I did it right. And that calculator method may not be necessary for a 2 by 2 because it's pretty easy without it, but when we get to the 3 by 3s, that is going to be. Okay, second quit, and second matrix, go to math. Number 1 is determinant, and then we have to tell it to find the determinant of matrix A. Enter. Tells us negative 38. Remember, the determinant is always going to be a number, not a matrix. If you guys had trouble and were unable to download the TI-84, there are other ways that you can get this type of functions online. I don't know if Desmos has it. I'm going to have to look into that, but there are definitely matrix websites out there. So if that is you, go ahead and shoot me a message and I can help you find something if you haven't already. Okay, so they've given us this equation. For just a second here, I am going to treat A, B, and X like variables instead of like matrices. So if we're X here, we would want to get rid of the 1/3 A, right? The negative 1/3 A. So I'm going to add 1/3 A to both sides of that equation. Okay, and then that gives me, I'm going to try and keep these equations looking nice here this time. Negative x equals 1/3 b plus 1/3 a. Okay, and then because that's negative x, the last thing we need to do, we don't want negative x, we want positive x. So I would just make everything inside of there negative. So negative 1/3 b minus 1/3 a. Okay, so if I was going to do this on the calculator, first thing, of course, is I need to edit my matrices. Down here is negative 1/3 b minus 1/3 a. I don't know if my picture's in the way, if you can see that or not. So I'm here, negative 1/3, and then I'm just going to use parentheses just in case, times matrix A minus 1/3 times matrix B. Okay, we got 3, 2 to negative 6. Make sure that matches. Beautiful. So if I wanted to do one of these equation problems by hand, I could. In this one, I went ahead and typed it out. Again, I want to start by treating this x and a and b like regular variables. So if I was trying to solve for x, I would subtract 1/2 a from both sides. Okay, and then that would leave me with negative x equals negative 1/2 a minus 1/2 b. And then I would want to get rid of that negative by multiplying everything on both sides by -1. So that essentially just changes the signs and gives me x equals, now everything's positive, plus 1/2 b. Okay, so I think what is easier, I could go in and take half of both of the matrices, divide everything by 2, and then add it together. But I could also, alternatively, just kind of factor out the 1/2 and then add together a and b while I definitely have whole numbers, then divide by 2. So I'm going to do it that way. So up here, let's go ahead and add together a and b first. So that top left, I have negative 6 plus 4. Top right, 6 plus 12, 6 plus negative 4, and negative 10 plus 2. And then if I want to go in and simplify, negative 6 and 4 makes negative 2. This makes 18. 6 minus 4 is 2. And then negative 10 and 2 makes negative 8. Alright, so then now that I have my a plus b, now I'm going to go ahead and divide everything by 2, or take half. So half of negative 2 is negative 1. Half of 18 is 9. Half of 2 is 1. And half of negative 8 is negative 4. And that should be my answer for x. Let's put it in, make sure. Alright, lovely. So we definitely don't have to use the calculator. I think all in all it's about the same amount of time actually. Okay, we are finally moving into matrix multiplication, aka this one, we definitely want to use the calculator. So first thing I'm going to do is enter my matrices, just like always.
This question is actually asking for both orders, A times B and B times A. Remember we talked about the non-commutativity of matrices? Well, we're about to see it. Can I go to second matrix, select matrix. Let's do AB first. A times matrix B. Okay. And then we can go in and do the opposite way, putting matrix B first, matrix A. And it does give us something different. So very important to make sure that we have the right order. I went ahead and entered these in. Just going to make sure that Delta Math agrees with our calculator. All right, perfect. So hopefully the calculations are working for you. The TI-84 does make this really nice and easy.
Okay, so these next set of problems are about writing augmented matrices to come up with a system. So remember with the augmented matrices, I went ahead and set it up here. The first matrix is for the coefficients. Okay. The second matrix is for the variables, and the last one is for the constants. So the problem with our equations here is that we don't really have them in that format yet. So I'm going to go ahead and put in another equation here. So right now it says 9y equals 8z plus 7. And I want to get my variables on the left, my constants on the right. So right now I have a variable on the right, 8z. So I'm going to go ahead and subtract 8z from both sides. Okay, and that results in so 0 x's, right? That's not written, but that's an important part of it because we also have x's in these equations. So 0x plus 9y minus 8z equals 7. Okay, so the way that I'm putting this in, that first column is my x's, the second column is my y's. So there are 0 x's, 9 y's, negative 8 z's, and that equals 7. Okay, so my variable matrix x, y, and z, that's not going to be part of the augmented matrix. So that's kind of going to be where like the line is in the augmented matrix on Delta Math when we put it together. But let's look at these other equations first. Okay, so the second equation, 3 plus 9z equals negative 6x. Okay, I'm going to do a couple things simultaneously here. Subtract 3 from both sides and add 6x. And that's going to cancel my 6x and my negative 3. So I'm just kind of getting things where I want them. So now I've got a 6x plus 9z equals negative 3. Okay, I'm also going to stick in there that there are 0 y's, because that's important. We don't want to forget about the y's. So back up to my matrix. I'm going to clear that off. I got 6 x's, 0 y's, and 9 z's. Okay, that last equation, negative 3z equals 2 plus 9y. And I want to get my y's over to the left side, so I'm going to subtract 9y. I have no x's again, so I can go ahead and put the 0x. Now I have negative 9y minus 3z. So last but not least, I'm putting those coefficients up here for the third equation. And that equals 2. Oops, I forgot to put the negative 3 here. Okay, so let's look at how we're going to put this into Delta Math. Make that a little smaller. So I'm going to take that 3 by 3 coefficient matrix, type it in here, and then the solution, that line, it looks a little off, so maybe this is what you guys mean by it's not looking right for you, but let's see what happens here. So I'm just going to say that line is before that one last bracket there. There we go. And so it comes up how it should look when you click submit. I don't know why it's so weird looking on the last screen. There we are. And we can do one more. Okay, this is a nice small one. So when I set this up, same idea, except it's 2 by 2, so I'm going to reset this up for a second. Okay, so this time I set it up to be an augmented matrix, so we're not going to enter the variables in there. I'm going to have that coefficient matrix is these 4 here, and then the constants on the right. That bar doesn't go all the way across, but you get the idea. So with the 2x equals y, I want my variables on the left, so I'm going to go ahead and subtract y from both sides, and that gets me 2x minus y equals 0. Now that minus y is the same as minus 1y, so my coefficients are 2 and negative 1. Make sure to put them in order. The 2 belongs with the x, so that goes in the first column. Okay, then the second equation, we have y minus 8 equals negative x. There are 2 things that I need to do here. I need to get that negative 8 over to the right side, so I'm going to put plus 8 on both sides. Then I also want to get rid of this negative x, move that to the left, so I'm going to put plus x on both sides. Okay, and when I do all of that, the 8's cancel over here. I just have x plus y, and then over here we added 8, so we have 8 equals 8. So of course, again, this is 1x and 1y, so I'm going to come and put 1 and 1, and 8 for the constant. And let's put that in, make sure delta math agrees. Okay, fabulous. I hope you found this video helpful. Please feel free to reach out if you want any further examples or have any other questions. Have a great afternoon.